Hello, am I audible? So, hello everyone, I am Himanshu. So, in this week tutorial, we are going to discuss about friction. So, this will be our last topic for the statics, and after this week, we will be moved to kinematics. So, in friction, we will be solving problems which are based on equilibrium, which basically we are doing since past 5 weeks. So, we will be using the concept of equilibrium and movement to solve or to resolve the forces, and the technique is more or less similar to the beam problem or the truss problem, where we actually draw the free body diagram, identify all the forces together, and then we use the force balance equation and the moment balance equation, and if it is in equilibrium, then they should be equal to zero. The summation of force and movement should be equal to zero. So basically the same concept we are going to use to describe the forces which is affected by the force of friction, or describe the frictional force itself. So until now we have considered the case where we ignore the frictional forces, but in this tutorial we will solve problem in which we have to consider the force of friction. So to understand a bit about it, you can imagine, so this is a classic example that you may find in any book, that you have a block which is residing on the surface, and of course you assume that now this surface exert is a rough surface, and therefore it is exerting some friction force. So if you are exerting any force P, there will be a friction force which is due to this rough surface in the opposite of P. So this friction force try to resist the external force, and if you are exerting a force P and the body is not moving, which means that this friction force, let me define by Fr, is greater than P. Now you decided to keep increasing the magnitude of P. So you keep increasing P and the motion is about to start, and in this condition the friction force equals to P, and this is known as the impending motion. And if the external force or the force that you are applying is greater than the friction force, what happens, this block starts moving, and this block is no more remain in the equilibrium condition. So we are going to describe such situations here, that for a various configuration we are going to apply some external force, or the external force could also be some in the form of reaction forces or weight itself, and due to these forces there will be a reacting friction force which act on the opposite direction, and then using the equilibrium equations, where we tell that the force in x and y or horizontal and vertical direction equals to 0 and the summation of movement equals to 0, we are going to solve such cases where the uh, complete system can be described not only by external forces or the reaction forces, but now also due to this friction forces. So for today's tutorial class, we are going to solve the problems using the equilibrium equations, where we include the effect of friction forces into the dynamics. So let's start with the first problem. So we will actually try to solve variety of problem. For example, we will solve some inclined wedge block kind of a problem, where we have an inclined plane and there is a block, and there we have to balance the forces and friction forces together and see and try to find the unknown. and then we will solve a ladder kind of a problem, which is you can find in any kind of a textbook. So in this problem you have a ladder which is inclined at the wall, and there are obviously the reaction forces which are exerting on the ladder, and you need to find the minimum friction force it required to keep the whole system in the equilibrium position such that this ladder does not topple or does not move. Then there are wedge kind of a problem where you have a wall and there are multiple blocks which are keeping in the wall, and here what happens that if you pull out middle or upper block or push it, what happens, this upper block will either go up or go down because of this inclined surface. And here you assume that at this contact between two box or two crate there is a friction force, and using the equilibrium equation you try to calculate the external force which is required to pull or push this middle crate in order to make this upper block either moving upward or in the downward direction. So most of our problem will be falling in this three category: the block in the inclined plane, or there could be different system also where you have a roller and it is attached with some rope or something. Then there is a ladder problem, which is I think only one or two problem I will solve like that. And then there are a couple of wedge problem. So we can start with a pretty much simple problem where we have a crate on an inclined plane. So in this problem, determine the minimum horizontal force P required to hold the crate from sliding down the plane. The crate has a mass of 50 kg and the coefficient of static friction between the crate and the plane is 0.25. So we have given this system. So as we discussed in the previous class, the first step is always to make the free body diagram, where we have to identify two things: the coordinate system that we are using and all the forces. So here the additional forces is the frictional force, so this is P which I require to find. This is 30, and I am assuming the inclined coordinate system such that this is my x, this is my y. So we have used this kind of coordinate system when we solve problem in trusses, and we saw that when we adopt this kind of a oriented or inclined coordinate system, the calculation become much easier. You can even consider a regular coordinate system, regular Cartesian coordinate system like this, and comparatively you will find that the calculation is little more tricky, I mean not tricky, more involved. So just to simplify our calculation, we adopt this coordinate system. Then the forces which here acting is weight, then there will be a normal reaction force, and then there will be a friction force which is acting opposite to the external force. So in this case it is P, but since, so here what happens that this block or the crate is actually trying to move in the downward direction, so there will be a friction force in the positive x direction, so it will be this. This will be 30, and this is also 30. So this is the free body diagram we have considered, and using the conventional equation that we are solving since 5 weeks, the equilibrium equations, we can actually find the unknown force P. So if we use the summation of force in the x direction, and since the system is in equilibrium, it is equal to 0, we have here p cos theta, and here we have to consider the component of weight as well.
Won't the weight one be 60 with the vertical? 60 degree.
Weight is 60, sorry.
The weight that is acting, wouldn't it be at 60 degree to the vertical?
uh, no, it should be 30, right? Because when you increase this incline, there will be a inclination here, there will be a rotation here also, so it will be at the 30, not 60. Because you imagine the situation like this, where this axis and weight is coinciding to each other. Now you start inclining this plane. Let's say this is 10, this is 20, and this is 30. What happens, you are actually creating this angle. So first it is coinciding, then what happens, it is also increasing when you increasing this inclination. So it becomes 30, is 20, and this is 10.
Okay. Okay. Okay, Manju, thank you. 30 from here, 30 degrees.
So you have this p cos theta, and then there will be a friction force Fs, which is in the x direction, and then there will be a weight which is minus W sine 30 equals to 0. So here weight is mg, which will be 50 multiplied by 9.81 Newton, and the friction force will be mu n, mu s n, so it will be 0.25 multiplied by normal reaction. So this will be p cos 30 plus 0.25 n minus 50 multiplied by 9.81 sine 30 equals 0. So this is equation 1. Because of course here p and n are the unknown quantities, so if we write down the equation where we do the summation of force in the y direction equal to 0, then here we will have n minus p sine 30 minus 50 cos 30 multiplied by 9.81 equals 0, and this will be our equation 2. So we can write n in terms of p. So from equation 2 itself we will have n equals p sine 30 minus 50 multiplied by 9.81 cos 30. So this is my n, and I can substitute this n.
Plus, plus, no, in the P sine
Yeah, yeah,
30.
yeah, yeah, it is plus. So now when we substitute this n in equation 1, we will have p cos 30 plus 0.25 minus 50 9.81, 0.5, which is sine 30. I'm writing as 0.5 equals 0. So this is from equation 1.
Could you please go to equation 1?
Yeah.
Uh, if that coefficient of static friction Fs is equal to
This
mu.
is mu n.
Okay, just a second. F of, so that's the force is equal to
Oh, this is n, normal reaction.
the, the reaction force.
Yeah, there will be a reaction force, right? When you have a friction force.
Yeah, yeah, understood, understood. But is that the that n is going there? Okay,
Hmm.
Fs friction force
Yeah.
is
So this n is due to this friction force, not this n, because this n is completely in y direction. So the
hmm,
component of this n is 0 in the x direction. So this n is coming due to this friction force. Not, this is not a component of this n,
uh, okay, just
because this
so,
is my n and this is
okay,
the direction of fs.
okay,
So this n is not in the x direction, it is completely in the y direction, and this
okay,
is the summation of force in the x direction. So, and you can see this friction force is completely in the x direction. So there is no component of friction force in the y direction. So you are writing Fs as it is. Then you write Fs as mu s multiplied by normal reaction n. So this normal reaction is coming due to this friction force. It is not this component here, because this n component alone is only in the direction of y. So
so okay, it's a little confused. So you're
so
telling that n component, if the friction was not there, if the coefficient of friction was not there, it would just be n, right?
no, there will be nothing then. I mean, because
So it would come
because
down.
this,
It would.
if the friction is not there, then this mu is 0.
Hmm. So
So
it would
this,
just.
yeah, so this quantity is the friction. It's a friction force. So this whole quantity is a friction force. It is not just a normal reaction. It is not a normal reaction force. It is a friction force. Only the thing is, you can write friction force in terms of normal reaction. That is the only thing. And here in the second equation, you can see there is no friction force, because friction force is not in the y direction. So you will have the whole component of normal reaction force. So
Huh,
what?
that was the question. So the normal reaction here, it's still due to friction only, right?
No, no, no. So what happens? Let's say you have a body, and for now you ignore the effect of friction. The plane is smooth. So since this body is in contact with this surface, there will be a normal reaction force here.
Okay.
So
Yes.
what happens when you write down the x and y component equation? Since there is no friction, Fs equal to 0, you will not have this term in the x,
Right.
in the equation 1, but in the
Yes.
y equation you can still have this n term, because here you will not have friction term. So this whole 0.25 n will be 0, but in the y term, since you can still have this normal reaction force, you will have this normal reaction, because in y equation this n is not coming due to the friction, this n is coming due to the normal reaction, but in the
Okay.
x it is coming due to the friction. So you can ignore normal reaction, I mean you can ignore the friction force, due to which this term is also getting out,
Got
because
it.
in the equation 1 it is coming due to friction, in the
So
equation
the
2, yeah.
friction force in x direction is 0.25 into the normal reaction, and there is nothing friction force in the y. There is no question of that, right?
Yeah, there will be no question of that, because this block can move only in the x direction.
X direction, yes. Okay, we got it.
Yeah,
Thank you.
yeah. So where we are, okay, so we need to simplify this equation, so it will be, so 0. Okay, so this is given entirely in terms of p, so we can solve for p from this equation. So it is 0.866p, and this will be 0.125p plus 106.196 minus 245.25 equals to 0. So you can club this p expression together and this expression together, so you will get so at RHS I am clubbing this term, it will be 139.054 and this will be 0.866 plus 0.125, it will be 0.99p. So p will be approx around 140 Newton. So this is my p, and if you want to find n, you just substitute p in any of this equation, either in this box equation or equation 2 or equation 1. So in any of this equation, when you substitute p, you will get n, which is equals 140 sine, so sine 30 is 0.5 plus 50 9.81 multiplied by cos 30, which is 0.8, so it is 424.773. So this will be 494.773 Newton. So just to recap, so here we have given the crate and we have given the external force, which is we have applied to the crate, and we need, and in the question we have given the friction force, the coefficient of friction, which is 0.25, and we need to solve for this external force p. So first, as usual, we actually need to make the free body diagram here and identify all the forces and the coordinate system. Once we do that, then we can use the equilibrium equations that along with the equilibrium equation, in which we consider force balance and movement balance. And using these two equations, we saw that we can able to identify two unknowns, which are p and n. Any question in this one?
No, Himanshu. Thank you.
So we can move to the next question. So here, determine the minimum coefficient of static friction between the uniform 50 kg spool and the wall, so that the spool does not slip. So here there is a coefficient of friction which is exerting between this spool, circular thing, and the wall. So there will be a point of, there will be a friction force at this point of contact. So this spool, so first when we make the free body diagram, you can see that this spool is trying to going downward due to the gravity. So the friction force will be exerting in the upward direction, and since there is a contact between this spool and the wall, there will be a normal reaction forces, normal reaction force at a point A. So first, as usual, we will make the free body diagram. this is 0.6, and this is 0.3 meter, and there is a weight which is acting. So this is point A, and there will be a normal reaction force, and there will be a friction force in the upward direction, which is mu and A. This is point B, and there will be a tension force on this cord, which is T.
Any reason you took NE as the subscript kind of thing here? Why not just N
I
or
mean, I want to show that it is
point A?
at point A. Yeah.
Okay.
So then we can proceed with our regular equations. So first we can use where we sum the force. So yeah, here I am taking the regular coordinate system x and y. It's a Cartesian 2D coordinate system. So when we use the first equation, which is the summation of force in the x direction equals to 0, then we can clearly see that there is a force Na and the component of T which is acting here. So here it will be Na minus T sine 60 equals to 0. So this will be equation 1, and we need to determine the mu. This is the unknown quantity here. So of course we cannot determine mu from the equation 1 because we required friction force. So when we consider the force balance and equate it to 0 in the vertical direction, then we can actually consider this friction force, which is completely in the y direction, and we will have a weight to balance it, and to balance it we also have the component of tension force. So there will be Fs minus mg plus T cos 60 equals to 0. So my Fs is mu, and A minus m is 50 plus T cos 60 equals 0. So here we have to determine this mu, but we can see that Na and T are also unknown quantities. So we have three unknown quantities: mu, Na, and T. So in the earlier question we have only two unknown quantities. So we solve for those two unknown quantity by first equation and the second equation. But now we write down the two equation due to this first two, when we consider these first two conditions. But we got three unknown. So now we need to consider the third equation as well. So we have to take the summation of movement. So if I consider point A, so if I take the movement at point A, then the summation of movement due to all forces should be equal to 0 at point A. So here I will have a movement due to mg weight, because it has a perpendicular distance, this perpendicular distance, and then I will have a movement due to so this is my Tx and this is my Ty. I am writing the component of tension force. So Tx is just T sine 60 and Ty is actually this T cos 60. So you can see this both T can create a movement across point A, because for Tx this will be my perpendicular distance, and for Ty this will be my perpendicular distance. You can see both are non-zero. So if I assume that the clockwise rotation along point A, the movement here is positive, and anti-clockwise rotation about point A is negative, then my weight is rotating in the anti-clockwise manner about point A. This Ty rotating in the clockwise manner, Tx is rotating in the clockwise manner about point A, and that's it. There will be no movement due to force NA and friction force because there are no perpendicular distance for them, and therefore this movement, which is defined by force multiplied by perpendicular distance, is zero because this is zero. So this we have discussed in detail in our first week class. So anyway, we have positive Ty and the perpendicular distance is 0.6. Then we have positive Tx and the perpendicular distance is 0.3 meter, and we have a negative mg multiplied by perpendicular distance, which is 0.6. 0. So my Ty is T cos 60, which you have considered in the y summation of Fy equation. So it is T cos 60 plus T sin 60 minus 0.6 mg, which is 50 multiplied by 9.81 equals 0. So I can take T as a common here, so it will be T cos 60 plus sin 60 equals, sorry, minus, here it is 0.6 equal to 294.3. So T will be 294.3 divided by 1.366. So this is 215.44 Newton. So this is my T. So I got T from this summation of moment equation. So
Not taken the distances there, I think.
no, I taken these are the distances 0.6, 0.3 and 0.6.
Yeah, but T cos 60 plus
Oh,
and
okay,
T
okay, okay, okay. Yeah, yeah, sorry,
that
sorry.
you are not multiplied
Yeah,
with.
yeah, yeah. Yeah. So this is 0.6. This is multiplied by 0.3. Yeah. So this is 0.6. This is 0.3. So this will be 0.3, and this will be, when you solve, you will get to 0.259. So you will have T equals 294.3 divided by 0.559. So this will come out to be 526.4 Newton. Is it correct? 0.3, 0.6, half 0.3. So this will be the T, 526.4 Newton. Then we cannot use, yeah, we can use, no, we cannot use equation 2 because here mu and Na are unknown. So we still cannot calculate mu because we need Na, known Na. So we can use equation 1 here because we already found T. Now we can actually find Na. So from 1, Na equal T sine 60. So my Na will be 455.875 Newton. This is my Na, and now I can use equation 2 because we found Na, we found T. So from this equation we have mu Na, which is 455.87 minus 490.5 plus T cos 60, which is T is 526.4. So it is 263.2 equals 0. So 455.87 mu equals 490.5 minus 263.2. So my mu will be 227.3 divided by 455.87. So this mu will be around 0.5. So this is my mu. So just to recap here, the concept was same to the previous question that we have used this equilibrium equations. So first we define the free body diagram, we identify all the forces, and then we proceed by using these familiar equations. So when we write down the summation of force equation in x and y direction, we found that there are three unknowns. So we need another equation, moment balance equation. So we will have three equations and three unknowns. So we know that when we use three equations, we can easily found all three unknowns. The remaining part is just an algebraic part. So from the moment equation, you actually found one of the unknown, which is t. So you found t first. Then when you substitute in equation 1, you actually found Na, and then from equation 2 you actually get mu, which is 0.5. So any question in this? Any doubt in this?
No, Himanshu.
So let's move to a different question. So again, it's a similar question, only the thing is we have a spring force attached, and in one of the class we show that the spring force can be given as the spring constant and the change in the distance. So this change in the distance is actually the original spring length, which let's say x naught, minus the final spring length, because you have the spring and let's say this is our original spring length. When you apply the force, when you try to push a block, this will get compressed. So this actually is delta x. So this is our original spring length, which is x naught, and this is our final one, which is let's say xf. And the difference between x naught and xf is delta x, which can be used in the spring force relation. So we, I think, solve one of the spring force problem in the equilibrium class, I think in week 2 or week 3. So this question we now solve with the friction force also. So there is a friction force, there is a spring force, and since there is an inclination and the mass of the crate is given, there will be a weight force. So all these three forces are balancing with each other, and we need to find this x here. Basically we need to find this xf, this length, final length of the spring. So in order to find the xf, and we already know the concept how we should start solving this problem using those equilibrium equations. So we know that in order to find this xf or this x, I need to find this fs, the spring force. So when we do the force balance analysis and equating it to 0, there will be a term which is coming in the equation, which is fx, which can be written in terms of k x naught minus sf, and there we can actually go with calculating xf know by knowing all other forces. So as usual, first we make the free body diagram. So this block is trying to go in the right direction, right down direction. So there will be a friction force which is acting opposite. And since this block is going to the right down direction, there will be a friction force also which is in the upward direction. So this is the friction force. This is fx. This is my weight, which is 490. Okay, let me write w. This is 50, and my coordinate system is inclined x and y. So this is my inclined coordinate system, because then what happened, my fx will be completely in the x direction, my fs and ff, spring and friction force, completely in the x direction. So this will simplify our calculation. So if I do the force summation in the x direction, then I will have here fx plus ff. So sorry, there will be a normal reaction force also, let's say n, because here we can write ff as mu n, and mu is given as 0.35. Spring constant, which is k, is given 660 Newton per meter, and my x naught, this x naught is given 800 millimeter. So fs, spring and friction force, then there will be minus w sine 50 equals 0. So my fs is k delta s, which can be written as k original length of the spring, which is x naught, and final length, which we need to find, plus friction force, which is mu na minus mg sine 50 equals to 0. So my k is 660 Newton per meter, and the original length of spring is 800 millimeters, so it is 660 800 millimeter, which means 0.8 meter, minus xf plus mu, which is 0.35, we don't know n, minus 50 into 9.81 sine 50 equals to 0. And this is my equation 1. Yeah, so there are two unknowns now, for now, n and xf. So if I write down my second equation and sum it to 0, then I will have this normal reaction force, which is balanced by the component of this weight force, which is w cos 50. These are the only two forces in the y direction. So it will be n minus w cos 50 equal to 0. So n equals mg cos 50. So this will give me n as 50 multiplied by 9.81 cos 50. So my n will come out to be 315.28 Newton. So whenever I write n, I cannot write Newton as n, because it will be confusing. So I will write hole. So this is my N, which is 315.28 Newton. Now we already found N, so we only have one unknown which can be calculated from this equation alone. So we don't need to go with moment equation. So if I use equation 1, I will have 660 multiplied by 0.8 minus 660 xf plus 0.35 multiplied by 315.28 minus 50 multiplied by 9.81 sine 50 equal to 0. So this will be 528 minus 660 xf plus 110.348 minus 50 multiplied by 9.81. So this is 375.744 equals 0. So this will be 660 xf equals 262.6. So this will give me xf as 0.39 meter, which is xf which is equal to 397.8 millimeter. So this is my final length of the spring. So just to recap here, in this question we have given the spring force, and we know that the spring force can be determined by this relation K delta x, and delta x is the difference between original spring length minus final spring length, and we need to calculate the final spring length in this problem. So we do the same, we use the same concept. We balance the force in x and y direction after making the free body diagram. So when we do that, in the from the second equation we actually determine N, because we got two constant here, xf and N. So from one equation we actually determine N, and then from equation 1 we determine the xf. So you can see that all of this problem can be solved by a single concept. In fact, in the previous weeks we saw that almost all the problems in the statics can be solved by these three equations. So only the thing you need to do is to make the free body diagram, identify the forces, and make a suitable coordinate system, either this kind of an inclined or the regular one like this. And after that, use this equation. So everything, most of the thing can be calculated by these three equations alone. So any doubt in this question? So we can move to the next one. So here we have again inclined kind of a problem here. So this is, I guess, the last inclined problem. Yeah. So in this problem we have given these three ropes, and there is a tension which is acting on these three ropes. So one of the tension forces given in this last rope, which is T, and we need to determine the tension T which is necessary to pull the box up the surface at a constant rate. So we have given the weight, and there will be a friction force also. So we can see, so when we make a free body diagram here, so here since there is a tension force which is acting on this cord, so this cord will experience the tension, and this cord will also experience the tension, same tension, and this cord is also going to experience the same tension T. So the resultant tension force here will be 3T. And since you are actually pulling out the cord, what happens, you are trying to pull up this box. So this box is going in this direction, you are pulling this box in the upward direction, so there will be a friction force here in the downward direction. Let's say this small f, and then there will be a weight always in the vertical direction. This is 60 and this is my weight, and there will be a normal reaction. Let me define this by NA, because then there will be a confusion between Newton and N. So this is NA, and our inclined coordinate system is like this. Okay, this is my y and this is my x, because now I can write, or I can show this tension force completely in the x direction, and I can show this NA completely in the y direction. So the force, friction force and this tension now completely in the x direction. So if I do the summation of force in the x direction, record it to 0, I will have 3T minus F, and the component of weight, which
Why is it 3T?
because
3.
because this tension is actually exerting by this cord, but the other cords also will have a tension force which will be equal to T. So all these three part of the cord will experience this tension force T. So this summation of all tension force due to this different three part of the cord will become 3T.
There is totally one tension acting, right? The one that is pulling it
No, so
upwards.
there is a tension which is acting on this cord. It is showing the tension which is acting on this cord, because you are trying to pull this part of the cord, but when
Okay.
you try to pull this the last part of the cord, this and this will also start experiencing the tension force, because you are pulling only the last part, but ultimately what is happening, the another other two parts of the cord is also start experiencing the same tension force, and therefore in this arrangement the total tension force due to this three part of the cord will become 3T. So you can imagine you are actually pulling only the last part of the cord with force T, but now there is a T here and there is a T here as well.
Okay. It's okay. I think I have to read up on it. Eh, Maybe I don't know the concept, so
No,
it's
no,
okay,
so
man.
no,
I'll just.
so you can actually visualize this. So you can actually visualize by pulling only this part. You forget about this interior part. Only
Okay.
try to pull this part of this cord with tension T. Let's say you know the magnitude you are using it to pull the cord, and you are actually applying force T to pull this cord. When you
Got
do
it.
that, now there is a distribution of tension occurs in the entire cord, and this distribution is separated by this rollers here, so it will distribute the same force T in other part of the code also. So this, so what happens if you now apply T here, there will be a T in all part of the code, but if you have this roller joint, it will distribute this T, same T in different part of the code. So this is actually due to this roller which are actually trying to distribute the same force in the other part of the code. If you remove this roller and if you think it as a single identity now, then definitely there might be a single T force which are acting everywhere on the card. But due to this roller, what these rollers are doing, that they are trying to distribute the same amount of force in the other part of the code also. So it is not actually like a single identity, it is actually a three different identity experiencing the same magnitude of the force.
No, no, I got it. I'm just not sure like how the roller works. Like distributing exactly the same force within the three, right?
Yeah, so what
So,
happens, let's say you have a roller here.
so here the length of the what do you say? The length of the string and the angle at which it is there, nothing will matter.
No, nothing will matter because let's say you have a roller here and you have a two different side of a cord. Now
Okay.
let's say you start pulling this cord by some force T. When you start pulling, in order to in order for system to be remain in equilibrium, you are actually avoiding this part of the roller going upward. So this also should experience the same amount of force T here. So you can
Okay.
see that this part, when you apply the force T here, now this part also experiencing the same force T
Hmm.
in order to be remain in the equilibrium position. So this is what exactly happening here. So when you are applying T here, in order to remain in the equilibrium, this also should have force T, and since now this is T, again from the same concept, this part also should experience T now, because you are exerting, you are pulling this part of the cord. So in order to avoid motion, here should be the same force. This end also should
But
experience the
the
same force.
directions will also be the same, like for them to add up.
To remain in the equilibrium, the thing is the summation of force should be equal to 0. So the direction
So
might have
TTT, right?
changed.
So that's the only. It's okay, Manchu. You can go ahead. I think I have to spend a lot of time on just the understanding how that works. Tension. It's from my side, so I don't know it. So I'll do that. Maybe next week I'll be better with it. Right now it's confusing for me because I don't understand the. I know you're trying your best, but I am very confused. That's the only problem. Like even if you explain right now, I may not understand because I have a lot of questions on how the roller works and the angles and all those things. So maybe I'll just prepare and come next week.
Yeah, I mean that is fine. I mean, so here we are not actually really concerning about the roller mechanism. The
Yeah.
only thing we actually need to keep in mind that the force should be distributed by this roller in order to remain the system in the equilibrium condition. So if you are exerting some force here at the right hand side, the left hand side should also experience the same force. That is the only concept we need to imagine here,
Got it.
because otherwise there will be no equilibrium condition at all. The entire, you can actually pull this entire rope and the system will be in the motion. So similar, so this is the example with two cases. You have a two side of the rope, the right side and the left side. Here you actually extending the same concept with three sides. So you have T here. Now if you are exerting T here, there should be same force which should be in the between, and
Yes.
since now there's T here, there should be a same force at the extreme other end. That's the thing. So there will be T T T, so this will become, cumulatively this will become 3T.
Total forces. Okay,
because
Manchu.
you can also imagine like this: when you are actually trying to pull this sorry when you're actually trying to pull this part of the rod, This is also experience the tightness or the forces. This is also experience some tightness of forces, right? All three part is actually experiencing some force, tight force, which is trying which is avoiding the falling of this block. It is
Yes.
not only this part which is tightly experiencing forces, and this part is not. It's not like this. All the three part are experiencing some forces because they want to avoid falling of this block. This you
Mm.
can imagine, right?
No, no, I can imagine.
Yeah.
That is not an issue at all. But it's still that is what I'm saying, right? I'm a little confused on why 3T and only T. I know you've tried your best. It's just that I am confused. So I might have to prepare a lot more from my side. I'll do my homework and come. I just don't understand the 3T part, which I understand the concept because there are rollers and there are three tensions acting on each string and all. I just want to just read through the literature of it and understand why it does it like happens that way, so
Okay.
that there will be less. Right now I'm confused because I've never done strings or ropes or pulleys, so I'll from my side I'll prepare and come next week.
Okay. Okay. Sure.
And thank you for the explanation.
So for this one, there will be a 3T, there will be a F, and there will be a NA. And if you do the force balance in the X direction, it will be 3T minus F minus 100 multiplied by 9.81, which is the weight, multiplied by sine 60 equals to 0. So again, this T and F are the unknown quantities, so you need one more equation. So yeah.
Also, just one more question. Like you had used the word static friction in the earlier problems. In this, they have used kinetic friction. So, what is happening here and what is not happening there?
So in this question, what is happening when you try to pull this cord? This block is start impending the motion. This block is start moving in the upward direction. So in
Okay.
that scenario, you can actually use the coefficient of kinetic friction. If
So,
you pull
it's the
this,
same concept, exactly the same
not
equation. So,
exactly, the equation should be the same. So here you
okay.
will have kinetic coefficient multiplied by the normal reaction. For the
Okay.
static case, you will have static coefficient of friction multiplied by the normal reaction force.
So, the ones we had where the crates were on an inclined plane, there it should be kinetic only, no? Because there also it would move if the either the spring is removed or if the force is removed from there.
No, so what happens there? So here, this system is no. So what happens? This system actually move, but after some time, it actually stops because spring will have a limitation. The final length of the spring will have some limitation. After one point of time, this whole system should be at stop or at the equilibrium condition. So in that case, you have to use here the static coefficient of friction, because let's say this is the original spring length. This is
No, that I understand. So if the springs just compress to its maximum, then it cannot move again beyond
yeah.
that.
So we are actually interested in that scenario when it actually compressed to a maximum. That's all. So that maximum compression we actually calculated.
Okay, but okay, take the earlier example where a force is being applied, right? If the force is removed, it's going to come down anyway. So in the tension, in the latest example that we were doing, it's the same logic, right? If the force is removed, it will go down.
But now this scenario, it actually crosses the impending motion limit, where our static force and the external force is equal to each other. So in that case, what happens? The motion is now yet to started. So when the motion is yet to started, then this is we call as the impending motion. And after this, we actually usually take the kinetic coefficient of friction.
Okay, 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 Manju.
Yeah.
Okay. So basically, the kinetic coefficient of friction only starts after a certain,
Yeah. Yes.
like after the mu s into n ends.
Yeah.
This
So
is
this you might actually seen in I think friction versus external loading diagram where it should be something looks like this. So what happens that you have a block, you have a force, external force P, and there will be a friction force Fs. So what happens, you apply some force P, and when your force P is very less than friction force, then your body will not move, and you are somewhere here, your body will not move. But what happens when you start increasing the external force, you are actually climbing this plot,
okay.
and there is a condition here when your friction force equals to the external force, and this is called the impending motion limit. So in this case, now body is now yet to move. Now body will now prepare itself to move in the direction of the external force. Now after this condition, which is at the maximum here, which I am describing in this box, after this condition what happens, the friction force when greater than sorry, the external force now greater than friction force, then body will start moving, and now this limit is actually described by the kinetic coefficient, whereas this limit is described by the static coefficient.
Static code. Got it. This makes sense. Yes. Thank you, Manju.
Yeah. So we actually try to keep ourselves at this limit, not we are not trying to going uh, at the extreme right limit, because we don't want to mess up with our equilibrium conditions, overall equilibrium conditions. Since we are using the equilibrium equations, we are restricting ourselves that the body has the impending motion. It is not now start keep moving in some certain direction, had some certain velocity which is changing, have some non-zero acceleration. So we
Got it.
don't want to mess up the idea of the equilibrium, because if it has the acceleration, then the summation of force will be equal to max. It
Hmm.
will be not equal to zero. So we will in this problem also we will be in this at this point.
Okay.
Yeah. So this is my equation 1. Now I can write equation 2, sorry, equation for the vertical direction, and it will be an a minus w cos 60 equals 0. So I can get na from this equation, because I can write na equals 100 multiplied by 9.81 cos 60, which is 0.5. So my na will be okay. So my na will be 490.5 Newton. So then, so this F can be written as mu kn a. So then I can use equation 1, because the only unknown is now t. So using 1, we have 3t minus mu k na. Mu k is 0.35, n is 490.5 minus 100 multiplied by 9.81 minus sine 60 equals 0. 490.5 multiplied by 0.35, which is 171.675 minus 100 849.57 equals 0. So this is 1021.245. So my T will be 340 Newton. So this is my T. So we have done nothing new here. So only the new thing here is the distribution of tension across the various part of the cord. So it's actually become 3T because every part of the cord will experience the tension force, and that's why the overall tension will become 3T here. So after that the problem will be the usual one. You make the free body diagram and use the equilibrium equations to find two unknowns. So here you got two unknowns. The first unknown was Na, the second unknown was T. So when you use equation 2 or the summation of force in the y direction, you actually can able to find Na, and when you substitute Na in equation 1, you actually found T, which is 340 Newton. So any doubt in this question?
Just hold here. I'm just looking at the free body diagram. 60. It is acting downwards. Why is the friction force in this case acting downwards?
So if the
All the
body is moving in the upward direction, you are actually pulling the body in the upward direction. So the friction will always in the opposite of the motion. So whatever is the direction of motion, friction will always be in the opposite side.
pulling the body the upwards direction. Therefore, friction force is in the downward direction. Okay, so basically way the way we are applying force determines the direction of friction and not how it's going to fall down, right?
Basically, the direction of motion describes the direction of friction force. So if the body is moving in the downward direction, then the friction force would act in the upward direction. But since body is moving in the upward direction, the friction force should be in the downward direction.
So in the problem one where the crate is going downwards, why have we taken it as it's going upwards? Yeah, in this scenario,
Yeah,
why?
so in the question it was given that in order to avoid the sliding down the plane, so we
Hmm.
need to avoid this crate to slide down. So this crate is going is want to slide in the downward direction because due to the gravity, and therefore the friction force should be in this direction because this crate has a tendency to go downward direction, go in the right down direction.
So similarly, in the latest problem, the weight has the tendency to go down, right? We are pulling it upwards.
Yeah, we are pulling it upward. Since we have a kinetic friction, this has the condition of an impending motion. So the impending motion is now started because of this kinetic friction we have considered here.
Okay,
Because
this one term I have to. It's called impending friction, right?
uh,
No, I'll read into it. No
yeah,
problem.
it's an
I have not
impending. It's an
I have not gone through those lectures, so that's why a little confusion. Read about it.
because of this impending motion. I mean, it's just a motion which now started take place because you applied the force which is almost equal to the friction force, and that's
Got
why now the motion is begin to started, and due to the motion, since you are pulling in the upward direction, the motion will be in the same direction. So the motion will be in the top direction, in the upward direction. So there will be a friction which is in the downward direction.
Got it. Got it. So if it was a static friction case, it would be the
Yeah, yeah.
same
If
concept as before
Yeah,
here.
so if it would be a static coefficient of friction, then this has a tendency to go down. So we could have considered friction in the another upward direction.
Upward direction. Okay. Thank you very much. What was the value of T? Final value of T?
It is 340 Newton.
Okay.
I
Thank you.
mean, precisely it will be 340.4. So let's move to the next question. So this type of question you might have seen in various textbooks. So you have a ladder and you have a friction forces between the point of contact of ladder with the walls, and you want this ladder to remain in the equilibrium condition. So basically here you want to avoid the toppling of ladder. So if this is the ladder, you want to avoid this ladder to be fall down. So for that you have to consider friction forces at either two point of contact or at least in the one point of contact between wall and the ladder, and that friction force try to put this whole system in the equilibrium condition, because you can see there are only the normal reaction forces which can balance this friction force, and also the weight. There is no external forces which are acting on this ladder, only the normal reactions and the weight which can balance the friction forces. So in this question we have given the mass of the bar, which is 4 kg. Coefficient of static friction between the bar and the floor is zero point 0.3. Neglect the friction between the bar and the wall. And if alpha is 20, what is the magnitude of friction force exerted by the bar on the bar by the floor? So in the first part we have so here we have a weight, and there is no friction force between wall. So this is my wall and this is floor. So there is no friction force between wall and this point, which is, let's say, my A, and this point is B. So no friction force at point A, but there will be a normal reaction force because this part of the ladder is actually in the contact with the wall. So there will be a normal reaction Na, and there is a friction force which is acting in the acting at point B. So now you can imagine that if this wall, if this ladder slips, this part of the ladder will slip in the downward direction, and this part of the ladder will go in the right side direction. So what happens? This is my the ladder position. It will slip like this, like this. So basically this part is moving downward and this part is moving in the right side direction. So at this point my friction should be opposite of motion, which is this direction, which is F here.
But why will there be no friction at A then? Like because it's still.
No, it's given the question.
Oh, okay.
So there will be F, and there will be a normal reaction force also at B, which is NB. Sorry. So we have identified all the forces here. In this there is an angle 20 degree. So this is 20. So we have identified all the forces here, and now we can use equilibrium equations. So first we will, as usually, start with summation of force in the x direction and equate it to 0. So this is x and this is my y. So if I do the summation of force in x and equate it to 0, I will have Na, which is balanced by F, and there will be nothing. So Na minus F equals to 0. So I can write F as Na minus F, which is my mu, NB equal to 0. So this is my equation 1 because here I only knew mu. So mu here is 0.3 and weight is mg, which is 4 multiplied by 9.81 Newton. So two unknowns we get, Na and Nb. If I do the summation of force in the y direction, I will have W and I will have Nb. So Nb minus W equals 0. So this will give me Nb equals 4 multiplied by 9.81. So Newton. So this Nb will be 39.24 Newton. So now I got Nb here, but still I cannot solve. No, I can solve equation 1, but we need to find the friction force F. So yeah, I can solve equation 1. So this is my Nb. So my Na is mu Nb equals 0. So my Na no, why equation 1? So we can directly solve by using the friction force relation, which is mu Nb here. So my F will be mu, which is 0.3 multiplied by 39.24. So this F will be 11.772 Newton. So this will be my friction force which is acting. So I don't need to use equation 1 also, because I mean you can use equation 1 to find the normal reaction force at Na, but that is not our objective in the question. We need to find the friction force for this case.
Both are same. So
Yeah.
could you just go to the question? I just want to see what are the assumptions. Mass of bar is 4. Coefficient of between bar and the 4 is 3. Neglect friction between bar and wall. And okay, what is maximum bar and not slip? Okay.
So in the first part we need to calculate the friction force, and that is coming 11.772. In the second part we need to find the maximum angle for which this bar will not slip. So we have this angle alpha, and in order to this bar let slip, what happens that one should have the force or the friction force which is acting here. It should be I mean there should be some mechanism or some force which should act on the bar, which should overcome 11.772 Newton force. So the maximum alpha is such that we consider Fb in the equilibrium. So what happens if I take a moment along some point? Let's say if I take the moment along point B, then I will have a movement due to weight and due to Na. And there will be a alpha angle here, and the perpendicular distance is this and this. Okay, and this is my, I have given 1 meter here, so this is my perpendicular distance for NA, and this is the perpendicular distance, sorry, this one, this is for W. So this distance I can write in terms of alpha. Yeah, so in order to find this alpha, we can actually take a movement along point B, and there will be a movement due to NA and W. So NA has a perpendicular distance of this, so this distance we have not given, but we have given this 1 meter distance, the height of the ladder. So we can actually find the perpendicular distance for NA. So basically this distance, which is equal to, so this is my 1 meter, so this distance will be equal to x by 1 equals cos alpha, so this will be x cos alpha, and this let me define this by y, and this distance will be x 0.5 sine alpha, because I am considering only this part, which is 0.5 meter, so this will be 0.5 sine alpha. So these are my perpendicular distances for NA and W. So NA will have rotating sense of clockwise, and W have a rotating sense of counterclockwise around point B. So if I take a movement along point B and equate it to 0, then I will have NA, and the clockwise movement is positive and anti-clockwise is negative, so this will be NAY minus W x equals x by 2 equals 0. So this will be NA cos alpha minus W, which is 39.24 sine alpha divided by 2 equals 0. So from this relation we can actually calculate alpha. So if you divide this whole equation by sine alpha, so I can remove this part. No, sorry, if I divide this equation from cos alpha, then I can actually remove this part. So it will be NA minus 39.24 divided by 2 and sine alpha divided by cos alpha. So this will become tan alpha. So this is NA minus 39.24 divided by 2, which is 19.62, tan alpha equals 0. And NA we can actually calculate from equation 1, because we already have calculated NB. So from equation 1 we can calculate NA. So NA from equation 1 is equal to mu NB. So this is mu NB equals 19.62.
It's equal to F only. So it's the same, right?
Yeah, it is equal to F. 11.772 divided by 19.62 equal tan alpha. So here you can actually find this alpha from this expression. Because otherwise there is no other way to find the alpha, because when you do the force balance analysis, all the forces are either in the x direction or y direction. You don't have any component of force where you can write force as some cos alpha or some f sin alpha. All the forces either in the y direction or in the x direction completely. But when you use the moment equation, you can see that this perpendicular distance now can be written in terms of alpha, because you have given 1 meter distance. So from the moment equation you can actually find alpha. if you have force and any other force like this which have some component of alpha, then you don't even it depends on the problem, but you may able to find the alpha by the force balance equation itself.
The W acts exactly at the center of the hypotenuse, right?
Yes.
So does that mean it also acts at the center of the base? Because we've taken directly x by 2. Is that
uh,
always, or I don't know, geometry can be
Not
sometimes.
exactly. So I think if we consider this triangle, so this is my alpha, so this is my 90, so this will become 90 minus alpha. This angle will be 90 minus alpha here. Now this is my 0 0.5,
Hmm.
so this distance will become x divided by 0 0.5 called cos 90 minus alpha. So this will be 0 0.5 cos 90 minus alpha here. So
Which is
this part should be,
21 as alpha is sine alpha, right?
yeah, this will become sine alpha itself, x
So,
equal 0.5
sine
sine
alpha.
alpha. So yeah, this we will get the same equation that we have used here, 0.5 sine alpha. So any question in this problem?
Just one second, one second. X equal to, so we took that. Okay, so now the angle you took right now, right? So from the 90 minus alpha, whatever, that triangle,
Mm-hmm.
that x is different, and the x you took there is different. The main triangle, the first one you took, right? That's the complete thing is taken as x there.
Mm-hmm.
And here, okay, okay, this becomes sine alpha by 2, right?
So earlier I actually put 0.5 sine alpha here,
No,
but
no, no, correct, 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 correct. So now it becomes sine alpha by 2, which is
yeah,
point.
yeah. But then in the moment I put by 2, so I removed 0.5
Yes,
from here.
it's more important. Correct.
Yeah. So we can move to the next problem. So let me move
So
to
the final answer was what? 31 degree?
this. Yeah, yeah, it's 31.
Okay.
So this problem I can skip. You can try solving this problem. It's a similar concept using the free body diagram, identify the forces and use the equilibrium equation. Let me move to this problem.
So to get these questions, I have to go to the lectures only, right? Again? Or
No, no. So this question I actually upload video and PDF. This PDF in the drive. So this
oh,
PDF
the
will be in the drive.
PDF is also there. Okay.
Yeah, yeah. I mean this whatever I'm doing in the class, that PDF will be in the drive.
Including the markup, or it's just the plain
Yeah,
questions?
including the markup.
Okay, okay.
So yeah, here we have given the 45 kg disk rest on the surface, for which the coefficient of static friction is mu a, point 0.2. Yeah. Determine the largest couple moment m that can be applied to the bar without causing the motion. So we have a friction force which is acting at point A, and we need to determine the movement which is acting here. So the only way to determine this movement is to use the movement equation, because this movement can be captured only in the movement equation. This movement cannot be captured in any force equation which is written here. So we can actually divide this problem into two. First, we can consider only this part where we have a disk. We only can consider disk here, and then we can consider this bar separately. So what we can do when we so we have to make two free body diagrams. So let's say first we consider only a disk here. So this is my disk, and there will be a weight which is acting, and there will be a movement of this bar which is rotating in this direction. Maybe it will try to move disk in the right direction. So the friction force will be in the left direction, and there will be a normal reaction force Na here, and this friction force will be equal to mu Na. And since there is a joint at point B, let's say here, so due to this pin joint there will be two normal reaction forces which is acting. See, this is Bx and this is By. So what we can do in order to find this movement M which is exerting on this rod here. Now when we make this free body diagram of the rod, there will be a movement, and then there will be these two reaction forces Bx and By. So this will be a rod, so there will be reaction forces Bx and By, and then there will be a movement M. So if I take a movement, let's say along this point, then I can consider this movement in the equation, and I can consider the movement due to these forces. Then I can actually calculate this movement. But in order to do that, we first need to calculate Bx and By. So in order to calculate Bx and By, we first consider this system where we consider a disk. So first we consider disk, and our objective here in this problem to calculate Bx and By, because once we get Bx and By, then we consider a rod, free body diagram of rod, where we have a movement and these forces Bx and By, and we can use a movement equation directly to calculate this movement. So in this we have mu which is 0.2. So now we can use the equilibrium equation here, where fx summation of fx equal to 0. So here we will get minus f plus bx equal to 0. So my bx will be f, and my f is mu Na. So bx will be 0.2 Na. So I don't know Na, so I can use another equilibrium equation where my force, summation of force in the y direction equal to 0. So in this case I will have W minus By plus Na equal to 0. So my Na will be W plus By. So W here is 45. 45 multiplied by 9.81 plus By. So this is my equation 1 and this is equation 2. So again you can see
Just one general question: like, if there is a surface and if there is a box or whatever, right? How is a friction determined? Who determines the coefficient of friction, or how is it determined, or is it standard for some like material?
I
How
think
much?
I think one of the way to determine friction is from experiments. I guess because there is no theoretical. I mean, apart by doing the force balance analysis, if you just want to determine the friction, I don't think there is any mechanism of doing that. I mean, my expertise is not in actually in this solid mechanics, so I cannot provide a detailed answer in this.
Okay.
But I believe that it is from the experiments and some numerical simulation. Maybe you can determine the coefficient of friction.
Okay. So there is no like problems or theoretical this thing. It's just depending on what the situation is, just to play around with it and tinker around and find a value which makes sense for that
Yeah,
surface.
yeah. So in undergraduate level, mostly it's like if you have given the coefficient of friction, then what will be in change in the force, or if you have given the forces, then what will be the value of friction. It's like that. But if you have nothing and you just determine, let's say, if I put some object in this table and what will be the friction force when this object moves. So in a more general case, I should say maybe the
Okay, even
experiments will be
yeah,
nothing.
that is correct. What you said, like we can just put the forces,
Yeah,
keep applying forces until it starts moving.
yeah,
And maybe that okay, okay, makes sense.
yeah. I mean, but this equilibrium concept also has some limitation. Like you have only three equilibrium equations. So
Mm,
in case if you got more than three unknowns, so
yes.
then mostly it will be like using numerical simulation or experiments to find the coefficient of friction.
Got it. I am also very new to this, so a lot of things are confusing. Like what happens when there is like right now we take simply supported beams for three supports, and what if there was like a fixed support at one end and another end also fixed support? Now we cannot do it using our equations because the number of unknowns are more. So what happens then? Even I don't know. Like how do people solve? Because those scenarios do exist, and what happens? I don't know. Any idea? Like if there is a fixed support on one end and fixed support on another end, now then some angled force is applied in between. So what happens now? Like,
I don't remember actually this exactly how I studied in back then in undergraduate level, because the thing is now my research area completely lies in the fluid mechanics domain, and I don't
okay.
exactly remember this solid mechanics
Does
concept.
this like whatever the concepts we learn in statics, does it help in fluid mechanics or like some sort of basic?
It can
Uh,
help actually. So for example, let's say you have a beaker in which you place the fluid,
hmm.
then what happens, then you can actually uh, balance the forces like pressure forces and the weight of the fluid together. So in the fluid statics, you can actually do that where you are actually balancing the pressure force and the weight of the fluid, and then you use the equilibrium equation to calculate the unknown required unknown. But that is very specific case when mostly when fluid is in the quiescent, when the fluid is not flowing. Only in such cases you can use
So the
equilibrium.
dynamics part that will come in this course, at least will that help like in the dynamics, like when the velocities of fluids and all those things are there. So at least some concepts are common between these here and there.
Uh,
The dynamics of fluid and the dynamics whatever we find
yeah,
here.
only to a some certain level. I mean, not always, but only it actually depends specifically to the problem. So in the dynamics, let's say you have a particle which is moving. Let's say so. Basically, in research, like mostly people are interested nowadays is to calculate the trajectory of a microplastics in the oceanic flows. So let's say you have a surface waves or ocean, and you have a microplastics which is floating at the surface of the ocean. So researchers now are very interested in this trajectory, that how this particle moves. So in that case, you can actually use Euler equations uh, where you identify this particle as a rigid body and you have a flow field. So from the Euler equation, you can actually describe its rotational motion, how it's rotating. So from the kinematics or the kinetics part, you can actually describe its rotation or maybe its translation motion.
So
But
the Euler equation will come in the kinetics part here in this course. Will it be
yeah,
used?
so there will be. I mean, I have to think. But yeah, Euler equation will be there. So I basically it also depends. Like yeah, Euler equation will be there. So it actually have a form of like this. I think like this. It has a form. I don't remember. Okay.
And it's okay. Formula I don't know, but
Yeah, this kind
with
of,
the
so it has,
concept.
yeah, so it has this kind of a form. So this actually represents the variation of angular velocity in time, and this part is actually the torque. So when you solve this equation, you can actually describe the rotation of microplastics in the oceanic floors. So this is only when you have a transient change in the angular velocity. But let's say you have, so this is for non-zero angular acceleration, because this part will give you the angular acceleration. But if your angular acceleration is zero, then you will have this, the total torque equals to zero. Then you can actually use this equation when, for the case when the acceleration is zero, angular acceleration is zero, then you can use simply use this equation to describe the rotational motion. So for a single particle case, or even for the multi-particle case, you have a multiple microplastics and you ignore the interaction between these microplastics, you can directly use, I mean, the Euler equation alone can describe the dynamics of a particle. But if you have this interaction between microplastics and several other things which are going on in the ocean, then along with the Euler equation, you have to use many more things, many more
Yeah,
concepts
that
to,
is a different world
yeah,
altogether.
yeah,
The scenarios that can happen, that is,
yeah,
there is no limit to it. Like
yeah.
you cannot anything.
Yes, yes. But as of now, whatever we are doing, it's like we are doing A before moving to B, C, D, E, F, G. We are
Hmm.
just starting with A.
Will this help in a corporate scenario? You know, because I used to work where like it was an engineering job only, all the companies, but I don't know if you have worked in corporate. The work usually is much simpler than what they say it is, right? And you do the day-to-day job. Now, so I took a break to study all these topics. So, in general, will this help, like in a real job scenario, like these 2D problems and the static equations, or do things get too either too complex, or any idea on like if your friends are working somewhere
Uh,
in a field where it's statics or mechanics are important? Do
that
they use all these equations, or do they do completely different something?
that I can't say. I never worked in corporate. I mean,
Yeah, that's the problem. Corporate is a weird place because they shield you, right? Like the general population doesn't know what is happening inside. Once you go inside, there is nothing happening. It's very simple work.
but yeah,
Yeah,
few people who after like masters or at least PhD who joined and who has a profile of CFD, who are doing CFD analysis like simulations and all in the corporate,
yeah.
maybe they use more of these equations because
And they do. That is what I was trying to tell. Like there are like usually 10% people in the whole organization that will be doing a very complicated job, 10 to 15, and the rest 85 will be just supporting those. Like they are already telling you what to do, but this has to be done every day for these many years. That job gets transferred to the rest 85%, and you understand that the simpler work. So
yeah,
that so even I don't know because I'm very new to these topics. I don't know how it will be utilized. See.
yeah. But after mostly PhD or MS, people actually try to join those CFD profiles and all, and
No,
when they
no.
join and
After
they,
PhD means they know that you are a research based person. So there, all those smaller things like it's not a hourly based thing where it can be said that after 8 hours you'll get that answer. No, right? You have to just there is a problem. You have to solve the problem. Now you don't know how much time it will take. Now that is where the PhDs and all the in depth knowledge will help. because, for example, you are designing a landing gear for a certain aircraft. Now you don't know whether it will take 1 year or 5 years, if it's a bigger aircraft and if the way it is going to land or something, right? But what happens is once the landing gear is done, like once the design is done, now the maintenance and all those things, now everything will be standard after that, right? The
Yeah.
smarter people or the PhD guys, now they design the part. Now all you have to do is everything is done. Now if this lands like this way or this crack happens, you have to repair it this way. If this happens, repair it this way or something like that. Now that's like 85% of the job for the rest of the people. Like products are like 1 lakh landing gears are there of similar design.
Yeah.
You just repair it this way or maintain it this way or that. So the 15% or the 10% whoever they have designed the landing gear, which is a very complicated.
Yeah.
You don't even know like what happens and how many forces you have to take into it. And then there are no materials which can withstand that much forces also. So you have to be smart enough to what do you say modify your design that way, even that like the forces have to be minimal. So many constraints are there. So I don't know if I'll ever reach there, but just that I wanted some sort of technical like fundamental engineering work where even if I don't work in corporate anymore, I can utilize it. Now, what was happening in my work, I'll just tell you,
Mm.
even though I'm digressing. Like, there's so many airlines and everything, so I'm giving them solutions, yes, but like if I leave the job, like if I leave that profile, then I cannot really use it in my day to day. Like, if I want to start something, like if I want to develop a product or something, I cannot use that knowledge, right? It's
Yeah.
just very specific to airlines and how they want certain data and this and that. So it gets useless, like in terms of transferring that workbook. Now, if I go to a automobile manufacturer, it's much less serious there. Like this, they don't need that much accuracy. They don't need that much data. They don't need
Yeah.
that much monitoring. It's just sell the car, and if it's sold, it's done, right? With airlines, it's completely different, where everything has to be monitored, everything has to be on point. So it's a very different world. So I did not make sense to me. Like we cannot really uh, you can do it for 5 years, 6 years maybe, but you can do it for 30 years. And if you are done for 3 years, it's the same thing. There's no real difference. It's just that you are repeating the same work again and again and again.
Mm.
No solution as such. It's just that human problems, like something happened within the airlines and you're giving the solution, but it's not engineering problems. It's
Mm.
just
Right. I got.
corporate is a little that way. And uh, what do you say, what can your educational field, it's completely different. It's like it goes way too deep and sometimes cannot be applied to real. I don't know, trying to find some balance. Let's see.
So where do you work now?
I don't know, I've taken a break. I had a health issue, so health and so then I thought, okay, anyway, break is there, so might as well just get my fundamentals right. So that's why I'm doing all this. Like, I started with a few other courses, but then realized, okay, it has to start from zero. You cannot again, even though I've done engineering like 8 9 years back, so it's zero now. Like, I think it's zero because all these small things you cannot really just revise, right? You have to redo the problems like 100 times to understand what is going on, what is going right. So I just thought, okay, I'll just start from the bottom and see what happens. For you, it's like you're from IIT Madras, right? This is IIT, and
Yes. Yes. Yeah.
so now for most of you guys, it's if you're not in corporate, it's a little out of touch, right? The two worlds are not colliding properly. I think that should happen here. In the other countries, in the UK and all those things, directly the people are directly working on the like the PhDs and the masters, whoever are pursuing in the college, they're directly working on the jobs with the problems
Yeah. We are also working on that. We have also a lot of project from the industries.
directly, right?
Yeah. Yeah.
So these guys, the Airbus, the Honeywells, do they come to you guys for fluid mechanics and all those things, or
No, but we have a project. I mean, I should not
corporate?
say
Yeah.
specifically to my lab, but in our department, if I tell about my department, then we have a project from ISRO, Microsoft,
Yes.
Saint-Gobain, like that.
No, that is what I'm saying. So this ISRO, you leave it because ISRO has that collegiate thing anyways, like ISC and all. They'll use your labs and they'll use your knowledge. But this corporate, I'm telling in general, like every corporate in the other countries is working with
Yeah, we have also project from like Microsoft and
Yeah, that is annoying. Microsoft is a very, because they need artificial intelligence. It's a very in-depth thing. The
yeah.
mathematics is very in-depth. So that's why they are coming for the last few years here. But other companies, no, they have not done it well. I That is
Hmm.
what I think. Now they have understood, because the engineering depth needed is so high, and you cannot do it with just like 500 or 600 people within the industry, because there are 1,000 products. They cannot work on everything, so you need to get into touch with all these students and PhD guys and pay money, and give them 5 years or 4 years or whatever the period is. Now that is where the problem comes in corporate. They don't like a lot of projects in India, at least long term, they don't think of, because after 4 years, if the design is not successful, or if it's not successful, all the time is gone, and so
Hmm.
that is the limiting factor. But now they realize if they don't do it, they'll be like left behind. Now Microsoft is doing that because of that same reason, because
Hmm.
all the math and all those things that you guys know, a lot of people in corporate will not know, and you cannot go and teach them from bottom, right? They have their day job to do also. So they are someone who is already doing all these things. They need to incorporate it. So the Microsoft, I think Samsung also is doing now. So if you see all the what is it, continuous courses there, no, CC courses and all. Now all these companies are sponsoring those courses. They are paying the money and putting these people for 6 8 months on these courses, so that they start from beginning. Because now they realize because the research is actually coming to India, right? Earlier it was very minimal.
Yeah, yeah,
Now,
that's true.
now a lot of things are happening. Like no one wants to just be dependent on the. Usually, what the culture was like, other countries, there'll be the R&D centers and they'll tell you what to do, and then
Hmm.
we would support. Now, a lot of things have moved. But the labs is difficult. Corporate cannot have its own lab for everything, so they have to go to colleges, and now it's happening. Let's see. I think
Yeah.
it's getting better.
Yeah, I mean, this situation improves in the recent past in
Yeah,
past
that's
past
right.
years.
Because now they are trusting the students also. I think like earlier they were it felt a little bit of like they were not giving that much importance to a regular employee. Now that is not there. Like if you give them the time and space, they will also do like as much as your compatriot in other countries will do. So I think that they have understood now. It's only a matter of are you ready to give them the time and the lab? Because if you don't give, how is it possible? Like, you have to test the products out, the labs have to, and labs are very costly, because 500 companies are there in a similar domain, and there are like 20 30 labs, and the labs are completely booked by someone, because these are all long term projects, and there are a lot of testing goes on. People with money can get it done, but like a mid-scale company, it's very difficult to get a lab for a
That's
day
true.
or 2 days. So now that all those issues are popping up very highly, because the Indian companies or the Indian subsidiaries of the bigger companies from outside, they want all the research work also. They are done with the repetitive jobs. They don't want repetitive jobs too much now. It will be done
Hmm.
by whatever AI or whatever. It will be done by something else. But these research-based jobs or whatever the more technical jobs, they want those work here, and once that happens here, the trust will also improve from. If, for example, Airbus gives a project to an Infosys and they do it very well, then Boeing will automatically come to them for these difficult jobs.
Hmm.
And then the repetitive jobs is nothing, right? If they're doing this complex jobs, then they will also do that. So all the projects will come. But to do that, they have to put in the lab and all those things, which they are not doing for individual products. They were just either sending a few people to on-site for a few days, but that doesn't work. You cannot just send someone who is not doing that work for at all, 3 weeks there, and then he comes back. Then he's not going back again for that particular lab thing. So there is no continuity, right? Between the testings and the results, and what happens if once you come back you realize something is wrong and you have to retest it. Now you cannot go that, it's expensive, you can keep doing that. So in Honeywell also we had the same problem. The lab testing, their electronics labs are very well in Honeywell, but the mechanical labs and all those wind tunnels and all those things, we don't have it within it. While I was working at Honeywell, so we had to go to certain organizations where they had these labs, and it's very 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 expensive, because everything is booked, and valuation just goes up for those
Yeah,
hours
yeah.
depending on how much the demand is. So let's say, I think now from now on the PhDs will be more demand, especially the AI thing, because the math side they have realized that you cannot just get it done from an average individual. You have to go to someone who has spent his last 5, 6, 7 years just doing that. So now the importance has shot up suddenly. Like earlier they were not. I don't know. Like they were not treated as important as they are now.
Yeah. Hello. Hello. Can you hear?
Sorry for
Hello.
digressing from
Huh.
the very good.
Hello. I cannot hear you properly.
I can hear you.
Ah, no, not fine.
Okay. Yeah, I mean, I said sorry for taking your time,
No,
like
no,
the last
no,
10 minutes,
no, no.
because I don't know if you had to complete that problem, whatever. But
Yeah, no issue. I will complete this problem and then can.
yeah, so it's additional 10, 15 minutes for you. So
No, it's fine. So yeah, so we have used the force balance equation in x and y, and we have three unknowns. We have Na, we have Bx, and we have By. So now we can use movement along the center of this disk. So let's say this is O. So if I do the movement balance at O and equate it to 0, the movement will come due to uh, By, which has the perpendicular distance of this, and friction force, which has the perpendicular distance of this. And in both the case, it's a radius of disk. So this will be Byr minus Fr equal to 0. So this will give you By equals F, which is equals to mu and A. So this will tell that my By equals to mu Na, which is my equation 3, and my equation 1 tells that my Bx is also equals to mu Na, zero point 0.2 Na, which is mu. So this is zero point 0.2. So from equation 1 and equation 2, I can say that my Bx equals to By. So if I use all this equation 1, 2, 3, I can actually directly write Bx, which is equals to By, and it is 110.4 Newton, and my Na will be 551.8 Newton. So this is my Bx and By. So now we found Bx and By. Now I can consider this rod. So this is my free body diagram for the rod. So this will be Bx, this will be Vy, this is Cx, and this is Cy, and this is the moment which is acting M. So if I so this is C and this is B. So if I take the moment along point C, I don't need to consider Cx and Cy because there will be no movement due to forces Cx and Cy, but there will be a movement due to the forces Bx and By. So this is my perpendicular distance for Bx, and this is my perpendicular distance for By. So if I take the moment along point C and equate it to 0, so I will have Bx with a perpendicular distance of 400 millimeter, and another is of having the perpendicular distance 300 millimeter. So this is 300 millimeter and this is 400 millimeter. So this Bx is trying to rotate in the clockwise sense, By will also try to have a clockwise sense, and m is anti-clockwise. So m equals bx 0.4 plus by 0.4. So b is same, bx and by are equal because of this relation we have. So it will be 0.4 plus 0.4, sorry, this is 0.3. So m equal b multiplied by 0.7. So my m will be 110.4 multiplied by 0.7. So this m will be 77.28 Newton meter. So just to recap here, we need to find the moment m here in this problem, and we know that in order to find this moment m, we should use the moment summation of moment equation. Only then we can find the moment. And if I do the summation of moment equation, I need to consider this reaction force bx and by. So I actually separated out this problem into a disk and a rod. So first we considered the free body diagram of disk, and we calculated bx and by because that is required to calculate the moment m. So we use the force equilibrium equation, f summation of fx and fy equals to 0. And we also record another moment equation to calculate bx and by because there were three unknowns, bx, by and na. So using this three equation, we actually calculated these three unknowns. Once we got bx and by, then we actually make a free body diagram of a rod where we identify forces bx and by and cx and cy and a moment m. But if we take a moment along point C, then we don't need to bother about cx and cy. So we can actually consider this moment and moment due to bx and by, which we already found. So from this moment equation alone, we can able to find the moment, required external moment which is acting here, 77.28 Newton meter. So any question here?
No.
Okay.
What happens if no one comes? Like, I think I'm the only person, right, here, other than you.
Yeah, so this video I have to upload in the YouTube. So anyway, I have to
You
take.
have to do it, yeah. Irrespective of if someone joins or no, you have to just finish
Yes,
it.
yes.
Okay.
So yeah, that's it for today. We
Yeah.
will see one more wedge problem for friction next week, and then we can start with kinematics.
Okay, Manju. Thank you.